This is a guide to the Arduino LED audio spectrum. Hopefully this will clear up any issues that you may have had with this instructables. So, I made a schematic. This is the spectrum shield. These are the LEDs, the resistors, and wires. The columns should be the ground pins. They shouldn't be touching the row wires. They should be connected to the resistors and put into their respective pins. And same goes with the row wires. They should not be touching the column wires. They should be put into their respective pins. So if you do not want to learn how the code works behind this, then just make sure that your setup looks exactly like this and run the LED spectrum code. Okay, this is the SparkFun spectrum shield. In my guide, I use an older model, but the newer model should work. By default, this shield uses digital pins 4 and 5 and analog pins 0 and 1. It has two MSG Q7 integrated circuits built into it, and these circuits allow us to measure 7 different frequency bands and get values that we can then compare to hard-coded values in our code to light up LEDs. So imagine these are the 7 different frequency bands, and we get values from each of them, and we can compare them to hard-coded values to light up the LEDs to the music. So say if this band returns a number and we will make it so it needs to be greater than 5 to light up this LED, it needs to be greater than 10 to light up these two LEDs, etc., etc. Alright, so this is a representation of an LED. In order to make it light up, the cathode or ground pin needs to be set to low, and the anode pin, or as I like to call it, power pin, needs to be set to high. And we can do this by using the function digital write, putting in the pin number that the pins are connected to, and either high or low as the second argument. Alright. So this is a small representation of 4 LEDs, and they're each connected by rows and columns. The columns are the ground or cathode pins, and the rows are the power or anode pins. Let's say we want to light up the bottom right LED. This row would have to be set to high, and this column would have to be set to low. So when we do that, when we set this to high, this LED turns on. And since we turn this row on, and this column is low, and this row is high, this bottom left LED would also turn on. So say we only wanted the column on the right to be on and the column on the left to be off, we would set this column to high. Since this is high, anything in this column will turn off because it needs to go from high to low. It can't be from low to high. It has to be from high to low. So this LED would turn off. We would have to turn this row to high and this column to low, which it already is, to turn on this LED. Say we want to turn on these 3 LEDs and leave the top left one off. Well, in order to turn on this LED, the top right one, the row would have to be high and the column would have to be low, which it is. So this would turn on. But since the column on the left is set to low and the top row is set to high, the top left LED will automatically turn on. So there is no way to turn these 3 LEDs on and this one off at the same time. There is a way around this. In order to get the 3 LEDs, the top right, the bottom right, and the bottom left on, with the top left off, we use something called multiplexing. Basically, we only turn on one column at a time, or one row at a time, whatever way you want to do it. So before I do anything, I'm going to set the rows to low, so that way nothing can be on. All these LEDs are now off. And I set all the columns to high. So, in order to light up an LED, the anode pin needs to be high and the cathode pin needs to be low. This is the exact opposite, so we're as far away from on as we can be. So, we want to light up these 3 LEDs and leave that one off. So we're going to do one column at a time. First of all, we're going to set the column to low. So basically turning the column on. And since we want this LED on, we're going to turn pin 2 on high. And since we want this LED on, we're going to turn pin 1 on high. So these LEDs would turn on. Alright, so we blink it really fast and then we turn it off. So now we're going to set this back to high and these back to low. Okay, and then we move on to the next column. We turn this column on low, basically turning the column on, and then we don't want the top one to be on, so we leave this on low, and we want the second one to be on, so we set pin 2 to high. So this LED will turn on, and then we turn it off by setting this column to high and this row to low, so it turns off, and then we just repeat that over and over again so fast that to our eyes it looks like these 3 LEDs are always on and this top left one is always off. Okay. This is the code behind the LED spectrum display. So I'm gonna go ahead and assume that you guys know how C++ works, how you guys know the functions setup and loop, and that you guys know what for loops and if statements are, and functions like digital write and pin mode, and what arrays are and what integers are. Alright, okay. In global scope, I created 7 integers that represent the column pins, going from digital pin 7 to 13. And then 5 more integers that represent our row pins, going from digital pin 6, analog pin 2 through analog pin 5. And then I made another int that represents the pin we will be using for strobe, as well as another int that we use to represent res. And then we have a left and a right array. These arrays will store the values we get from these 7 different bands. And then I have an int band that just stores temporary values. Then in setup, you can see that I chose 115,200 as my serial number I will be using. I declared all the pins I will be using, and I set the res to low and the strobe to high, setting up the MSG queue function. So in void loop, we call upon a function that I created. It can be named whatever it wants to be named. This is just the name I chose for it. You can swap the name for it. It sets the reset to high and then low, and then it loops through each band, and it sets the strobe to low, and then once it's done reading the band from analog read, it sets the strobe to high. So basically what this code is doing, from my understanding, it's taking the reset and it's bringing it back in line to start reading all 7 bands. And the digital write strobe is kicking it onto the band, and then kicking it onto the next band, then the next, and then the next, and then the next, and then the strobe resets it. And then we use analog read from analog pin 0 and 1 to store that value. Alright, so I edited the code a little, made it cleaner in the version I had posted. I had if-else statements declaring the pins as low in the statement and not beforehand. Made it so they're all turned off at the very beginning. So this is where the lighting up happens. This function void spec, you can name it whatever you want. It takes in the column that you're lighting up and the int height. The int height is the array value that we get from the MSGQ band. So it turns all the columns off and all the rows off, and then it turns the column on. And then these if statements just go through, and if the value is higher than these values that I hard coded, then it turns that row on, lighting up the LED. So if your setup's not lighting up to your music, it might be because the volume isn't high enough. For example, here's some values. Notice how it changes as the volume rises. Let's see, as I raise the volume, the numbers increase. So if you're running at low volume, you might want to change these numbers, make them lower, because I haven't designed it so it adjusts to the volume that you're set at. So it delays it at the very end after lighting up all the rows and the column, so that it stays lit. Try blinking an LED and delaying it, and around 6 or 4 you can actually see it blinking. Any lower than that, it looks like it's always on. So here in the loop function, we are reading the bands, and then all this does is print out those bands in the serial monitor. And remember, you need to be at 115,200 baud to view it, otherwise it just looks like rubbish. Alright, so then this just goes through every column and lights it up according to the value that we got from the read MSGQ function. And that's pretty much it. It's pretty simple. Take care. If you have any questions, leave it in the comments below. I'll try to answer them as best I can.